Next subject is pre-draft of IS 456 by Professor Rupen Goswami sir. So I request Goswami sir to start with the presentation, please.
Between U and T, so I will not take much time. Look, they have understood, they have given me warm water so that I don't bother you all too much. Okay, I guess this is also the moment, because IS 456 is something that is very close to all of us. I mean, right from this is the first love for any civil engineer, right? IS 456, and I have the responsibility of talking about that also. Okay, so let me begin. Very quickly, the first publication of IS 456 was in 1953, and we had working stress method. And I'm going to highlight few items just so that we understand the whole, sequence of things that are happening. It was for general building construction. It was stated. 57, we had the first revision, working stress method continued. 64, the scope was broadened to include, to make it applicable for all concrete structures. Okay, and then of course, what you see as M100 and 400 is not a typo. It was in the before the MKS or SI system, that is why it was written as M100 and 400. So basically 10 to 40 in today's context. But the important point is, as part of Appendix B, ultimate load method was introduced, and that is very important. And we had the introduction of the stress block that we know as of today. Okay, and if you see the stress block, it was 0.68 or whatever we call it, 0.67. That was the strength. Concrete ultimate strain capacity was 0.0035, which later was used in the 78 revision, which is the third revision, where we got our limit state method of design. And we continued with that same thing. So the first statement that I'm making today, which is a slide which will come at the end, is that today in 2024 as we stand, we are talking about structural design provisions which are 46 years old without any revision. So it's not just one generation, but multiple generations of engineers. We have been using the same design provisions. Another important aspect which was there in 1978 revision was this, requirement of design aids, and that is what we all know, SP16, SP, all these special publications. Very, very important. And why am I raising this issue? I'll tell at the end of this particular thing, right? And then, of course, this statement and attempt has been made to unify the approach of design of reinforced concrete and pre-stressed concrete, because this was foreseen in 1978, but we still had 456 for plain and reinforced concrete and structures, and then we had a separate standard for pre-stressed concrete. Today we are going to unify all three, and that is why I am showing all these important landmarks, so to speak, in the development of IS 456. But going back to the stress block, we basically took the ultimate stress block, again it used a partial safety factor of 1.5 and came down to this stress block that we use today for design of our structures. The 2000 revision, an important revision of IS 456, was important because for the first time the concept of durability came into in a big way, other than addition of our introduction of use of admixtures and so on and so forth. So basically we were moving from OPC to all the new cements and other materials that are coming in. But as far as structural provisions are concerned, we are still, there was only one change in structural design provision, that was of shear design clause. That too was in a little incomplete manner, but otherwise it was 2000 revision was primarily based for durability, right? we went with this, and the other aspect that happened was the concrete, look at this statement. For concrete of compressive strength greater than M55, design parameters given in the standard may not be applicable was the statement written in that standard. But if we look at ourselves today, we have gone well past all this. So essentially we are designing, building and constructing structures without any standard. That's the reality. So this is where we are. We are now working for the 5th revision of ISSE 456. And let us see what it is going to bring us this time around. Also parallelly, we are working on the 3rd revision of ISSE 1343. It is going to be superseded because pre-stressed concrete is going to be subsumed within ISSE 456. So let's look at the overview of the things that are going to come. Scope of revision, as I said, it's going to be an unified code for plain, reinforced and pre-stressed concrete construction, right? And precast is obviously not going to be part of that. So that is it. What are going to be the contents of the new revised ISSE 456? We can call them chapters, sections, doesn't matter, but essentially there are going to be 11 of them. Other than scope, reference and all, basis of design, design loads, structural materials, structural analysis, structural design and detailing, construction, inspection, testing and monitoring, and dismantling and demolition. So these are going to be the main sections under which the whole content will be presented. Design loads, Arleker already showed. Essentially, there are 2 types of loading, force and displacement loading, and there are going to be 10 force loads: dead load, imposed load, wind, snow, water, earth, blast, impact, construction load and pre-stressing, right? And 6 displacement load effects: temperature, creep, shrinkage, elastic shortening, foundation settlement and earthquake, ground shaking effect. So essentially when you say these are the 10 plus 6 loads, we will have load combinations also appropriately provided, which will have one or more of these different loads coming into the picture. What are the bases of design? So basically a structure, a reinforced concrete structure is going to be designed for 6 basic requirements. Obviously the first is, when we talk about design and what is generally taught in colleges, is provide strength, right? PU, MU, VU, TU, all strength, 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 strength. So that is what we talk about in our design code. So obviously strength is going to be the most important quantity, but then there is going to be design for durability, and that's going to be a new thing coming up in this particular revision. Obviously, once these are done, then there will be check for serviceability, and then there are the new 3 terms that we need to get used to slowly, which are integrity, robustness and restorability, and we'll see what each one of them are. So strength, I don't need to emphasize more, it's very fundamental to safety. So when you talk about strength and ISSE 456, particularly limit state design as was introduced in the 1978 version, we actually had definition of strength based on 2 parameters, 2 quantities: axial load capacity, axial strength capacity, and flexural strength capacity, bending moment capacity, were defined based on strain, based on limiting strain values, whereas shear and torsional strength capacities were defined based on stress values, right? So we have tau C max, and so on and so forth for defining shear capacity. But when you talk about moment capacity, for instance, we talk about under-reinforced, over-reinforced, whether the concrete has reached its limiting strain or reinforcing steel in tension has reached limiting strain. So the definition is based on strain. Now the ideal situation would have been to now, after all these years, move totally to strain-based definition. But we will not be able to do it even now because we do not have enough experimental data. So we'll continue with that. Serviceability, essentially, be it in terms of deflection, crack width calculation, or any other, vibration, acceleration levels, rotations, all these will continue to be carried out based on stress levels. So essentially what it means is that, and I'm going to say it explicitly, is that working stress method is going to stay. Okay? So engineering colleges have to go back and start teaching working stress method also, which we have stopped because we were told, limit state method of design is the best thing that has ever happened to mankind. Well, durability, in the previous presentation we have seen enough of bad situations. So here the idea is that there is going to be a part of design, and I'm going to talk about them, in terms of chlorination, carbonation, and sulfate attack. Also, the bigger challenge that we face today after 24 years, even if we can start from 2000, which is the last revision, we have an explosion of different materials and admixtures and mineral admixtures, chemical admixtures, and so many things, right? And that is really the challenge that we face, where we have a problem of plenty, so to speak, in terms of handling durability, and that is why it's also taking a little while to finalize this as this part of the standard. And obviously we'll have prescriptive limits in terms of free water cement ratio, minimum cement content, and the usual things. So they are going to be there. Then we're going to talk about robustness, essentially under blast, impact, and fire. So here we need to ensure that a structure has adequate strength, plastic deformation capacity, and rotation capacity to take between these effects. Integrity, again, essentially it's talking about redundancy, alternate load path, and inelastic deformation capacity. And definitely we have a huge stock of existing structures that may warrant restorability. Essentially, they are losing their capacity because of natural deterioration, and in addition due to overloading due to any one or more of those 16 different load cases. So sometimes we need structure to be restored, so therefore we need these particular things to be taken into account. So to summarize all this, this is again a load deformation curve capacity that should take back. This is something that I feel we should take back from these days' effort. So the first is strength, serviceability, durability will be there, an important part, and these are based on the force level calculations, right? Robustness is there, sitting there. Integrity is, it should not fall apart, the structure should not fall apart, and then restorability. So obviously what you can see is that leaving, if you leave durability aside just for a moment, strength and serviceability, linear elastic analysis, code-based design. So code comes in, gives you some force, gives you some ways to estimate strength, and you can be done with that. But the moment we start talking about robustness, integrity, and restorability, we have to get into understanding the actual nonlinear behavior of the structure. Now, this is where the whole challenge is. Do we have to do this for everything? So obviously no. So that's the sequence, if I have to put it, strength, serviceability, durability, and then robustness, integrity, and restaurability. So these are the these are the 6 items that we will have to talk, think of as structural designers. Do you have to do it for everywhere, for every structure? The answer is no. Obviously, the first 3, strength, serviceability, and durability, are mandatory requirements for all structures, right? And only in special situations, special structures where the owner specify this as a requirement, robustness, integrity, and restaurability will come into the picture. So don't, there's nothing to panic that it's not that our design will continue to be done the regular way for most structures, hopefully, right? So that is the thing that I have to say. So that's 1, 2, 3, and 4, 5, 6. So what are the major changes? So this is an important change, of course, conceptually this is how we have to look at the standard. What are the major changes? The first major change, why I mentioned about the chronology, was the grade of material. Remember, M10 to M40, then M40 to 55, and then suddenly you can use anything higher. This may not be applicable, and we left it at that. The whole idea was to go all the way up to 100, but the fact remains that we do not have test data. We have test data for materials test, but not even of structural member. Forget about structures, right? So the next proposal is to leave it up to M80, but even then we do not have test data. So the final conclusion may be, I'm not committing anything yet, to limit it to M60, till which point we have enough experimental data both from within the country and abroad, so that we can rely on, right? So as engineers, as students of science, we depend on proven data, and that is what is available till M60. The debate is still on. But the interesting thing, if you are going to stay till M60, then there is no issue. But otherwise, the problem was that with high strength concrete, one of the key fallacies is that high strength concrete is very brittle. We say that, but essentially what it means is that the 2 limiting values of strain, 0.02 and 0.35, do not remain fixed. And the implication of that is that the ductility of members designed with high strength concrete is very less. And that is something that we have not been talking about, because until now our design was only based on strength. We never looked at deformation. We never cared about deformation. So long we provided adequate strength capacity, we thought it is perfect. So that is the change, fundamental change that may happen. Okay. So that is it. Reinforcing steel, again we have the same problem of plenty, because 415 steel is anyway unilaterally stopped. The 500 and 550 grades are basically the same steel, sold as whichever grade you like to purchase, right? And 600, 650, 700 and so on, we are going on adding to that list without doing any structural testing. So the bigger question that at hand is where to draw the line. But I'm sure all of you agree that there has to be a line drawn somewhere, because without testing, without knowing anything about how a structural member is going to behave, I think it's risky to allow it. So that's where the issue is. With regard to durability, of course, mixing of different grades of steel has been proven to be detrimental for reinforced concrete structures, and that is something that probably will come in explicitly. There is another new concept which is doing the rounds, is about service life, and there's a proposal to allow designers to use design different structures for different service life. And this is where the durability design comes into the picture, and so that you as a designer can say, oh, this is my structure, and therefore I need not design it for 50 year or 75 year or whatever, I can design for, so this concept is another new concept that's going to come. I do not have time to go into the details of it, but I'm just highlighting the major conceptual things that you should be looking forward to seeing in more detail in days to come. Exposure classes remain more or less the same: mild, moderate, severe, very severe, extreme. The definitions are rewritten a little bit here and there, and that is how they are going to be. This issue of service life is going to be controlled by 3 parameters primarily: chloride, carbonation, chlorination, carbonation, and then sulfate attack. And particularly with regard to carbonation and chloride attack, there is going to be calculation of cover, the minimum cover, based on your exposure conditions and so on. So that is where a little bit of change. Earlier it was all prescriptive, so to speak. Now, depending on what you want, you should be able to calculate what is the minimum cover that's going to be required. So that is the idea. Sulfate, again, because of lack of enough experimental data, it's probably going to be, prescriptive still in terms of minimum grade of concrete, cementitious content, and so on and so forth, all these other parameters. Then, IS 456, when we began working on this, there was this whole idea of, since it's going to be the unified code and it was under BIS, there was an initial discussion about 456 talking both about confined and unconfined concrete. Traditionally, only in CED 39 or earthquake engineering code, we talk about ductile detailing and confinement of concrete and so on and so forth. But since 456 is still going to be the mother code for design of concrete structures, it was felt that this concept should come in IS 456 directly and not leave it for the earthquake codes 13920 to talk about it. So that is another kind of a change. Well, actually, I don't see much of a change because current 456 already talks about certain detailing, which is intended towards providing a minimum confinement, but not explicitly quantified and so on and so forth. But anyway, that is something that is going to be there. So we are going to talk about cover concrete, distinguish between cover concrete and core concrete. The use of structural wall, very important. Again, IS 456 already had provisions for walls, and it's again going to reinforce on that and bring it very explicitly and forcefully this time. For instance, any wall, any member that has only one curtain of reinforcement will not be considered structural concrete. Because this is like that Mr. Asrami in that Sholay film, आधा इधर जाओ, आधा इधर जाओ, half of the cover concrete goes this way, half of the cover concrete goes this way, बाकी मेरे साथ आओ, कोई नहीं बचा नहीं. There is no core concrete left, right? So single curtain of reinforcement is like that. Okay, so this is something that is going to happen. These kind of members will not be treated as structural concrete, and therefore the intent is, what does it mean? Practically what does it mean? It means that these elements cannot be relied upon to carry primarily gravity. Gravity, well, they will still carry, but lateral. And so you need to choose your structural elements accordingly. And it's for good reason. I mean, single curtain of reinforcement has shown poor behavior all through the history. Structural systems, this is where again lot of deliberations went on. Do we kind of talk about flat slab, precast, all these things? Because today what is happening is these things are not talked about. They are not part of the thing. I mean, flat slab is there, of course, but then they have become very major or very commonly used structural systems. So therefore, a need was felt to talk about them, give provisions, like what was done in IS 13920, IS 1893, in terms of buildings with flat slabs. So there were certain requirements in terms of at more stiffness, limiting drifts, and so on and so forth came. So here also similar things are going on, and we may see provisions for these in IS 456 also. Talking about post-tensioning and pre-tension, slabs. Again, there is a requirement in terms of minimum size of thickness, minimum thickness, minimum size, minimum cover, and so on and so forth. So these things will come into the picture. Structural wall I have mentioned. So essentially, structural walls are, the idea is to say that although it is IS 456, but do not leave the entire safety related aspects due to earthquake, wind, or lateral load, or blast, or because blast, impact, all are now coming under the purview of IS 456. So therefore, there is a need for IS 456 to talk about structural walls and make its use almost kind of mandatory in structures. Structural analysis design primarily will continue to stay based on linear elastic analysis. So all regular structures can be done, analyzed and designed the way we are doing currently, except for those special cases where we need to look at integrity and robustness. We may have to get into nonlinearness. And this is the departure, this is a significant change, an additional part that may come. Because these are becoming important requirements for very strategic projects, and so we cannot do away with these kind of things today. Explicit in terms of structural analysis, one of the key things that always happens is that this PT slab as part of moment frame building. Usually the building is designed by somebody, the PT portions are designed by somebody else, and they are just put together. And the point is, when the PT slabs are put and pre-stressing is done, we forget that the columns see additional movement. Right? Because it is done by somebody else, and I've personally seen situations where the columns do not have capacity, and then how do you salvage? So you start over all, and even after, and the bigger problem is once the construction is done, and when at a later stage all this is realized, then it's a mess. So we will see more explicit statements in terms of how to do structural analysis in such cases, and so on and so forth. Okay, the most favorite topic of limit state design. Essentially, as I said, strain limit based axial and bending moment capacity will continue to be there, and strength based shear force and torsional moment capacity will be provided. So that is what we are going to continue to do. But there is going to be a fundamental change here, and I want all of you to pay attention to this. So when you talk about axial and bending for our regular load strength capacity calculation or even PM interaction development, we talk about these limiting strains. So we have the limiting strain in steel 0.002 plus 0.87 Fy by ES, and for the limiting strain for concrete, let's say for flexural action is 0.0035. And so we draw the strain diagram, we write the corresponding, we draw the stress block, and then do equilibrium and find the strength capacity. Typically, what we see as MU, what is that U? We are still with the ultimate load method concept, and that is why we call ultimate moment capacity. It's not ultimate, we have already used factor of safety. It's not ultimate anymore, right? But we continue to use this ultimate word for the last 46 years. But that's okay. We can call anything, by any name. The point is, it corresponds to the secondary compression failure or crushing of the concrete. That is the whole idea, that concrete strain ultimately reaches 0.0035. What happens is, if you look at smaller members like beams, columns in building systems, there is no issue with that. Okay? the strain, the maximum strain, tensile strain in steel will be reasonable. But when we try to apply that same formulation to structural walls, okay, you have a 2 meter, 3 meter wall, and if the extreme compression fiber has to reach a point 0.035 strain, the tensile strain on the other side has to reach such high value that you will necessarily have very large crack widths. And that's going to affect the durability and subsequently everything else. Right? If this could happen, the fact remains that it never happens. And that is why everything looks okay. But the implication of that is that we are overestimating the realizable moment capacity of walls by a margin of 30 to 40% by doing this. Okay? In case of smaller sections, this difference between where drilling happens to that secondary compression failure, the margin, if you do calculation, you will see 1%, 2%, 3%, 5%. Not of worry. But in large cross-sectional walls, this can be 30, 40% difference. And this is a significant thing. Also, this is not the, this can therefore, and this higher strength, in particularly in walls, is not realizable. Because for the wall to reach that state, the entire structure is going to get badly damaged, and you do not want that. So therefore, the definition of flexural strength is going to be revised to from the secondary compression failure fracture level to this level where yielding actually happens, and that level of curvature is consistent with the crack width that you would expect for regular durability over the design service life. So that is going to be a change in terms of how the strength capacity is calculated. Okay, so that is what you have to pay attention to or look forward to. Also, it essentially means that the level of curvature that you will see in these cross sections will be consistent, as I said. So that is the. There is no change as far as basic calculation is concerned, except that the definition of strength. So we are not going to use ultimate strength. We are not going to use PU, MU, VU, TU anymore. We are going to call limiting strength or design strength. These are just going to be called design strength. Okay, and that is what. So you will see new symbols with new, we'll stop using of these terminologies, this PU, VU, and all that. Working stress, of course, will be there. So this is what it is. Ultimate load method gave us capacity there. Working stress gives us capacity here. But we used a partial safety factor and continued to call that ultimate strength. It was never an ultimate strength. Right now, the proposal is to use a strength which is consistent with the durability that we expect over the stated service life. And that is what is the change in definition of strength that is going to happen. The eternal problem that we face is between the definition of what is a column and what is a wall. Right? So, and it's good to be in the no man's zone. So, I'll not say, but maybe some amount of policing is going to happen there. Watch out for that. But the more important thing, we want to raise here is that, see, whether a vertical member is a wall or a column is not so much dictated by the aspect ratio of that section, but in terms by its behavior. So if you do the, if you look at the bending moment diagram, if you look at the shear force diagram, you will see whether it is actually behaving like a flexural member or is it behaving as a shear critical member. And that is what is important for structural engineers to look for, and not play this trick of controlling everything by the aspect ratio of the thing. So something towards that you may expect to see coming up. Beam column joint, IS 13920 brought in a big way. It's also going to come into the regular design of IS 456. In terms of pre-stressed concrete, there's going to be, since it is going to come into IS 456, this was also used as an occasion to revise and improve that, because at the end of the day, if the definition of reinforced concrete member, flexural member strength is going to be updated, so needs to be done for pre-stressed concrete. But not just that, both for bonded and unbonded case, now there will be no approximate table-based strength calculation required. The pure mechanics-based using equilibrium, compatibility and constitutive law, that whole process is now going to be given, so that we follow a consistent method of calculation, which also can be programmed, in any spreadsheet or computer program or whatever, and all these expressions will be, provided. So that is that. Working stress method, of course, we can't do away with, because we need to check that with deflection and all the other situations. So it will continue to be there. Although I, personally understood that probably there is some aversion towards using this word working stress method. We are good at finding way out. Detailing, this is not going to be allowed. In fact, even current one talks about 135 degree hook. It was, I don't know how it came into the being, understanding that IS 456 doesn't talk about 135 degree hook, only IS 13920 talk about ductile detailing. I mean, it was not the case. IS 456 did talk about it. But one change that's going to happen is that we are going to require one full complete hook for all members, particularly column sections. That is one thing that's going to be a requirement, and in addition to that, we can have cross ties, additional links, and so on and so forth. Spiral reinforcement is not helping. One hook alone is not going to provide neither the confinement nor your shear capacity. So this is another important thing, that all these members that we usually believe to be compression members actually also have to be designed for shear. And so that is something that will be stated explicitly. So only transverse reinforcements and individual hooks will be permitted, and of course with all the other requirements of detailing in terms of spacing, the hook length and so on and so forth will be there. The other important concept which was there but probably we never paid attention to is, of course, once we talk about confinement, we are going to distinguish between confined and unconfined to an extent. But one important thing that we will explicitly talk about is this balance point, and essentially tension control failure versus compression control failure, which is very clearly, which was given in, if you see all the charts in SP 16, if you remember all the radial lines, FYD is equal to, right? It was there, but we never talked about it very clearly. And so what happens is in our pursuit of making very slender members, particularly columns, we always had our design, load combinations sitting high up on the PM interaction. All those are anyway sitting in the compression failure zone. So not good in terms of achieving ductile response. So that also is something that may come in. Well, open ground story, and then comes the different types of systems, structural systems. Some mention about some of these things. Precast buildings is something that we, of course, it will talk about design of these, but essentially, as individual components. But as a system, there has to be a separate standard talking about precast construction. That is something that needs to be developed in the country, because a precast member cast and fabricated is not a solution for, is not the complete solution, so to speak. So we need to have those things. And And then of course flat slabs, so we'll have provisions for these also. But the point is that a lot of these things have been going on in a very unregulated way. And so if you see the scope of IS 456 today in 2024, if all of these things have to be addressed in one go after 46 years, that itself became a very huge task. Obviously, when we try to do so much in one shot, there will be misses and there will be mistakes also probably, but an earnest effort has been put in, but I'm not claiming that it is going to be perfect. The bigger challenge was that civil engineering structures will always be subjected to all these different elements of nature and different demands, and particularly and more so from different requirements that we set forward for ourselves each passing decade, and keeping pace with that itself is a big challenge for IS 456. So as I mentioned, these are the systems that need some attention. It's not clear as to exactly what to state and how to regulate them, but the discussion is still on, and in a way. We have already built many of these without any clauses, without any standard. Definitely the focus has been on use of these high strength materials, because this is the craze that appears to be unstoppable, right? Higher the strength is better seems to be the understanding, which is absolutely wrong. Sorry to say that, in the same breath, but no, I truly mean that. I truly mean that. We really do not need, for 99% of the structures that you build today, I mean in the country, you do not need high strength materials. Let me be very honest about it. Yeah, for special situations, special cases you may need, but for that you need to do testing and be 100% sure about what you are doing and do that. Nobody is going to stop that. But for the 99% structures that you are building in the country, you really don't need anything higher than what we have been already using. So yeah, so this whole discussion about, initially I said about 100 MPa is what was proposed. Then there was a discussion, no, we should allow up to 120, and then finally we realized that we don't have data even for 80. So that's the whole game that we are dealing with. Okay, so not just material test, because material, any material can be produced, and a standard can be created for that specification. For consistent manufacturing of the material can be generated, but the use of that leading to a safe, sound structure, serviceable, sustainable structure is what needs to be proved, and that has not happened. The challenge is that it's not about the material and all, but our somehow we have also faltered in our basic design aspect also, and so we need to be little cautious, and also the standard has to have precautions to avoid such silly mistakes, and that is where we need to ensure that a certain basic safety is guaranteed, right? And that is where code compliance comes into the picture, and the earnest request of, attempt of IS 456 is to ensure that there is certain shade of safety that is embedded in all structures that we produce henceforth. As I mentioned in the morning, eventually the purpose is to have a closed loop process, because if we are going to assess integrity, robustness, right, we need to have this, and that is a culture, a tradition that slowly needs to develop, and nothing better than IS 456 should be the starting point for that. It's not going to happen overnight, we all know that, but then if we need education and practice to move towards that, 456 has to take the lead and start talking about it, if not recommending it. So that is very clear. The other aspect is that we do not seem to learn from our past mistakes. This is a photo I saw 21, 22 years back, and I was curious to know what is the story of this. This is a father and daughter rebuilding their house exactly the same bad way. The way it was built and the way because of which it collapsed. Right? We have to learn from our mistakes. And so, we need to look at what are our priorities. Well, safety, functionality and sustainability are three items that we cannot negotiate, cannot compromise today. In 2024, standing in 2024, we cannot afford to have any compromise on these three items. Between aesthetics and economy, there we can choose which one to give priority depending on what type of structures we are talking about. Right? And if this is something, this is a philosophy that we all agree to, then definitely there's a way forward to develop our standard and then improve our practice in days to come. So, to summarize, this is where we are. I mean, in terms of structural design provisions, we have not made any change in last 46 years. So yes, there's going to be some change. I've already highlighted the changes. Let us not be fearful of these changes. It's time we look at these changes and learn these changes and start practicing them. That's the only thing that we'll say. Demand, of course, there are also additional issues that are left in terms of, we are taught characteristic load, characteristic strength, but we are not sure whether the values given in 875 part 1 to 5 are characteristic or mean or what. You can go today and try and open those documents and try and read and find out. And if you find out, let me know what they are. So, and similarly, there are issues related to other aspects. So there are a lot of, what I'm trying to say is that it's not that ISSE 456 is going to solve all problems. It's not that ISSE 1893 is going to solve all problems. There are a whole lot of things that needs to be taken care of collectively, simultaneously, and then only we'll have a better, more systematic, environment for structural design and construction. So we need clarity. We need clarity on not just some of these specific items, but also on the philosophy of design per se. I say that. The good thing is that on a working day, when I see the hall full in evening, I see that none of us are actually spectators today. Most of us are actually playing the thing, and that's a good sign for the country. And with that positive note, I think we can conclude here, but not before highlighting that you are going to see a new look to ISSE 456. Okay, don't get frightened. It may look scary because there's going to be some 1400 pages to it. It's okay, we can do it. We can do it. If we are going to 46 years, we can do it. Okay? But more importantly, what I want to use this opportunity to appeal to is that bringing out the draft of ISSE 456 is only the beginning. We can even publish the code. We need good commentary. We need good design aids. We need solved examples. And most important of all, we need textbooks, so that the next and the next and the next generation of engineers learn the subject and then they start practicing properly. Right? On this point, I just will read out a message I received from BIS, from Mr. Arun Kumar, Head Civil Engineering Division. He says that Bureau of Indian Standards is pleased to bring out to your attention an exciting opportunity for preparation of reference handbooks on Indian standards. The Bureau has recently floated request for proposal for preparation of reference handbooks on Indian standards on the curricular areas identified for various disciplines, all that. The invitation to proposal is open to all organizations, institutions and individuals engaged in scientific and or academic activities and who qualify the eligibility criteria as mentioned in RFP. The point is, today we are hosted by ISSE, right? It is organizations like this who should, in my opinion, come forward. People like all of you with so much of experience and expertise should come forward and help prepare the rest of the documents. Design X, right? Solved examples. That will go a long way in reducing the anxiety level, hearing that there's going to be 1,400 pages. So I thought I must use this opportunity to read out this message from BIS. All of us need to work collectively on this, right? So that is where we'll achieve this mission of technical capacity development in the country. We need to develop these kind of design charts and design aids to help explain behavior, explain structural behavior, and make younger engineers understand structural design. These are sample calculations, sample charts to show where a section becomes under-reinforced, where a subsection becomes over-reinforced, where the minimum transverse reinforcement versus maximum transverse reinforcement, what does it cause to a structural member in shear, right? Classical example of PM interaction, tension failure zone versus compression controlled failure zone, and things like that, right? So we need a lot of us to put in effort here, and well, there are some major changes and many minor changes because we are doing it after a gap of almost 5 decades, and this is where professional societies need to come forward and help us all. I know you all are very busy, but this is the honest request that I can make from academia side. Okay? Do support, advise, assist, guide, help, and I'm sure occasions like this where all of us spend a day on trying to understand what is going on and why it is going on, will go a long way. We need to do this more often, more frequently at many more places, and we'll continue to do that. But we also seek full support from each and every one of you. This is the BIS CET 2 Canon 5, which made 3 working groups, and some of us were involved with that. We are grateful to the chairman and other members here. I'll stop here. Thank you so much. Thanks to ISSE, SEFI, and of course VJTI.